Hello guys, welcome back, and for this video we're going to continue to do the derivative functions. So hopefully you still remember the first principle for the derivative functions, and just remember, if my fx is equal to the x to the power of n, then my f dash x just like n times x to the power of n minus 1, okay? And let's look at the relationship between the derivative functions and its original functions. So we can realize something like, if my derivative is a linear equation like straight line, then my anti-differentiation or my original function is a quadratic equation, right? And we can see that the turning point is a and b, and the turning point in derivative function is a0. And after a or greater than a, my original function is increasing, and corresponding to the derivative function is greater than 0. And same we can see over here, if my derivative function is less than 0 and my original function is decreasing. Okay, so with this idea, we can know one or three rules. Basically, f dash x equals 0 is going to be special point, or later we're going to call it stationary points. So this one is either turning point or point of inflection. And if my f dash x is greater than 0, then it applies my fx is increasing. And if my f dash x is less than 0, then it applies fx decreasing. Okay, this is the essential idea we're going to have over here to help us to draw the graph of derivative functions. Look at example 19. First, we have the equation A, which is a linear equation, and we know it's passed through -1, 0, and 0, 1, right? So we can write the equation if you want, and if we kind of slightly to start to write the derivative, then we know it's like just horizontal line, okay? And same over here for B is also the horizontal line, but the derivative is negative. And for C and D, we should be careful, because 0 to -1, it will be greater than 0, my derivative, because my original function is increasing. And from -1 to 1, my derivative will be less than 0, because the original function fx is decreasing. And after 1, my original function start to increasing, so my derivative function is greater than 0. Okay, this is the idea I was trying to say. And also for this one, see if this function is derivative. We're going to talk about this one more in 9M, so let's skip this part first. And for the next really important rule, or really important derivative, is called chain rule. Okay, chain rule is essentially for us to find a derivative for the composite functions. So in such case, let's say if we want to find this one, qx equals bracket x cubed plus 1 and overall square. And of course, it's pretty easy for us. We can expand the brackets and do it one at a time for each term. But just imaginary, we have x cubed plus 1 to the power of 30. So it's essentially impossible for us to expand all the brackets and get the derivative, right? So we need a bridge between them. Essentially, this is combined with two functions. You know, the first one is qx equals to u to the power of 30. So a polynomial, or I should say the power function. And inside the u, sorry about that, and inside the u is like u equals x cubed plus 1. So inside of it, it's a cubic function. which means we can easily do it, because if we use this formula, essentially this du can cancel with each other, so you still have dy dx is exactly as the left hand side. So let's do this one as an example. My y equals to u to the power of 30, and my u is x cubed plus 1. So my dy du is 30 times e to the power of 29, and my du dx is 3 times x squared. So I multiply this together to get 90 x squared e to the power of 29, and it's 90 x squared, and the u is like x cubed plus 1 over 29. Okay, that's the whole thing of it. It's pretty easy and straightforward. Okay, for this one, again, you need to look at what the inside function is and what's the outside function. Okay, so that's 9e for chain rule, and for 9f, again, it's pretty straightforward. It's just ask us the power now can be irrational instead of just integer. Again, we apply the same formula. Fx equals to x to the power of n, then my f dash x just n times x n to the power of minus 1 to the power of n minus 1. Okay, so again, it's essentially the same thing. This is 9f, and for my 9g is derivative of ex. I can directly write it. It's like ex, the derivative is e to the power of x. Okay, so essentially they are the same thing. And for this part, make sure you guys to know that my fx, or maybe I should write it like this, my y equals e to the power of u, my u equals kx. And after that, my dy du, just like e to the power of u, my du dx, just be the k. So I multiply them together, got k times e to the power of u, just like k to e to the power of kx. Okay? And that's it. Also for the 9g. And for my 9h, it's like logarithm. So if I have y equals log e to the kx, and my y is log e to u, my u is kx. So I can do the same thing. Then again, I will get 1 over x. Okay. And for 9i, the derivative of circular functions, again, we do need to really remember it. Sorry, yep. And if you like, you can use first principle to help you to prove it. And currently, we just need to familiar with the derivatives and can apply chain rule on it. Or later on, we're going to learn product rule or quotient rule on the requirement. Okay, so that's it. And 9j is pretty important later on with quotient rule. So this one we call it product rule. Normally, I suggest my student to remember like this: uv dash equals u dash v plus uv dash. Okay, this one is our product rule, and we can directly use by applying over here. So my u is x cubed, my v is 3x minus 5 to the power 4. So my du dx is just like 3 to the x squared, and my dv dx is just like 4 times 3x minus 5 to the power 3, then times 3. So it would be 12, 3x minus 5 to the cube. Then I just apply the formula u dash v plus uv dash to get the ideas. Okay, so it's pretty straightforward. And for this one, actually we don't need really to remember it because it's provided for us. And for this one, it's a quotient rule. So quotient rule, my suggestion is everyone remember in this one, u divided by v dash equals v squared u dash v minus u v dash. Okay, this is the derivative for using the quotient rule. So before I'm going to the limits or continuities, I'd like to stop here and just make sure today we cover the chain rule, product rule, and quotient rule. For my next videos, I will introduce you guys for some final year practice to see how they're gonna test you guys for these three rules. And I know these three rules go through really quickly, but you can, go through the proof yourself if you want, or you can just like directly use them. Okay, so hopefully my videos is helpful, and please subscribe or click like button, and I see you guys in the next videos. Bye bye.